Hello, math magicians. What I want to review with you today is the use of exponents. Are you ready? Let's get started. Okay, here's the big idea. Exponents are just a shortcut for writing a multiplication problem. The base is the number that you are multiplying. The exponent is how many times you multiply the base. A perfect square is a number that can be expressed as the product of two equal integers. Perfect squares can be represented by x to the second power, or x squared. A perfect cube is a number that can be expressed as x to the third power, or x cubed, where x is a positive whole number. Remember, exponents are just a shortcut for writing a multiplication problem. How would you write this number in standard form? 3 to the fourth power. To work out exponents, you need to think of them as multiplication problems. In this problem, the 3 is the number that you are multiplying, the base number, and the 4, the exponent, is how many times that you're multiplying it. So we can think of this problem as 3 times 3 times 3 times 3. Or another way to write it, another symbol for multiplication, is 3 times 3 times 3 times 3. We'll be seeing a lot of that this year. So let's do the math. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the answer to writing 3 to the fourth power in standard form is C, 81. There are some common misconceptions people make with exponents. Let's look at the mistakes that you could have made in this problem. For answer A, they multiplied the two numbers together. So 3 times 4 equals 12. For answer B, they took 4 to the third power instead of 3 to the fourth power. So they said 4 times 4 times 4 instead of 3 to the fourth power. The answer to this would be 4 times 4 is 16. 16 times 4 is 64. For answer D, they added the two numbers. So they said 3 plus 4 equals 7. These are all wrong. Let's look at another version of how you might see exponents. On the pretest, you saw 4 times n times n times n times m times m. If you were going to write this as an exponent, you would write 4n to the third power, m to the second power, or 4n cubed m squared. If there is only one base number or letter, like the 4 in this problem, you do not write an exponent for it. It's not necessary. How would you write 3 times 3 times 5 times 5 times 5 in exponential form? I'll give you a second to think about it. The answer would be written 3 to the second power times 5 to the third power. 3 squared times 5 cubed. How about C times C times C times C times A times A? If you thought the answer would be c to the fourth power, a to the second, then congratulations, you're absolutely on the right track. If not, don't worry. You'll have plenty of time to practice. In the course, you're going to have 2 places that you can go for help. In the course, you'll find that there are 2 places or 2 links that you can click on for extra practice. There's thatquiz.org and IXL. You'll find several links to both. One of them is an activity that you'll probably be doing in class, and one of them is just extra practice for whenever you want it. You'll find examples from all of these things that we've gone over together there. Perfect squares and root numbers. Perfect square is a number made by squaring a whole number or multiplying it by itself. These are all examples of perfect squares because the number times itself creates a perfect square. For example, 5 times 5 is 25, creating this perfect square. "16 is also a perfect square because 4 to the second power equals 16. The square root of a number is a value that when multiplied by itself gives the number. An example of this would be 4 times 4 equals 16. So the square root of 16 equals 4. When working with square roots, the symbol that you see looks like this, or some version of that. Let's see another example. The square root of 36 would be 6, because 6 times 6 equals 36, or 6 to the second power equals 36. To find the square root of a given number, figure out which number squared or multiplied by itself equals that given number. If you want to find the square root of 9, you would figure out which number squared or multiplied by itself equals 9. The number 3 squared equals 9. 3 times 3 equals 9. So the square root of 9 equals 3. Maybe these cute kittens will help you remember. You can also get the same answer by thinking of squared and square root as opposites, just like these 2 cats, black and white. You have squared, 7 squared equals 49, and square root. The square root of 49 equals 7. Opposites. According to the pretest that you guys took, you are all pretty strong with the order of operations. You seem to understand that PEMDAS is the way to go. You know that first it's parentheses, then exponents, then you multiply or divide from left to right in the problem, and then you add or subtract from left to right, of course. Let's try a couple examples of using exponents in the order of operations. We know that first we have to use parentheses. So in this problem, we would start with 12 minus 3. And we write the entire problem out in each step. That keeps us organized. So the longer the problem, the more organized we have to be. For this one, we start with 5 to the second power minus 12 minus 3 is 9, plus 6 divided by 2. Next step, we got rid of the parentheses, so we have to go to exponents. We have 25 minus 9 plus 6 divided by 2. Now, you guys are good at math, so I know you like to skip ahead, but it's really important to do one part in each step so that you have almost a triangle shape with your order of operations problem. Like I said, it's really important to stay organized when you get into this kind of math. So what's next? We go to multiply or divide from left to right. I see a division problem in there that we have to do next. This time, I'm going to have 25 minus 9 plus 3. Now all we have left is addition and subtraction from left to right. I end up with 16 plus 3. My final answer, 19. Okay. This time, I'd like you to try this one on your own. Pause the video and work it out on paper. Then continue the video once you have an answer, and we'll go over it together. Pause the video now. Okay, welcome back. Let's work out this problem together to see if you got the right answer. This is a pretty long one. We have to start with parentheses, but there's more than one function in the parentheses, so what would we start with first? Just like you see up here, we have to start with multiplication or division before addition or subtraction. So let's do the problem out. 20 minus 4 to the second power divided by 10 minus 16 divided by 2 equals 8 plus 3 times 4. Okay? Next, still have parentheses. We got to get rid of those first. 20 minus 4 to the second power divided by 10 minus 8 equals 2 plus 3 times 4. Next step, we're finally at exponents. 20 minus 4 to the second power, which is 16, divided by 2 plus 3 times 4. Next, we have multiplication and division from left to right. 20 minus 8 plus 3 times 4. Next step, multiplication still. 20 minus 8 plus 12. Next step, addition and subtraction from left to right. 20 minus 8 equals 12 plus 12. Last step, 12 plus 12, 24 is my final answer. If that's what you got, great job. You're definitely on the right track. That's about it for exponents. Now we just have to practice and do our activity. Do you think you have it? No? Watch it again. Think you have it? Yes? Great. You'll find an assignment attached to this post. Talk to you later.